Good morning, everyone. Sorry I'm not here today and that you're going to have to listen to one of these videos again, but it's the best I can do when I'm not here. So today we're going to be learning about the area of regular polygons, so that includes equilateral triangles and then regular polygons. So first let's start with an equilateral triangle. Remember that in an equilateral triangle all sides are congruent and then all angles are congruent, and all angles equal 60 degrees. So normally our area formula for a triangle is area equals 1/2 base times height. But when working with an equilateral triangle, our formula is a little bit different. Okay, and it's √3/4 s squared, where s stands for a side. Okay, go ahead and make another note card for this one. Definitely something that we need to practice. I haven't graded the quizzes all the way, just part of them is knowing our formulas. Okay, so here's another one to add on to it. Alright, so if we look at example, we know this is an equilateral triangle because all the sides are congruent. So s equals 11. So area of an equilateral triangle, I'm just going to go ahead and plug in the formula. Okay. And then leave that as a fraction with the radical. Some of you guys did decimals yesterday on the quiz. I did say to leave everything as a reduced fraction and radical. So we get 121 √3/4 inches squared. Remember to include units. Okay, and for the next problem it says find the area of the shaded region formed by the following square and equilateral triangles. So remember that a square, all sides are congruent. Okay, so we want the area of the square minus the area of the equilateral triangle. Okay, like I've stated also before, is that I think it's helpful to write things out like this. So area of the square minus area of the equilateral triangle, and then also to actually write out the formulas. So s squared minus √3/4 s squared before you even begin the problem. Okay. So now let's just go ahead and plug the numbers in. So 8 squared minus √3/4, 8 squared. Okay. So 64 minus 64 √3/4, and then you need to reduce, and you should come up with 64 minus 16 √3 units squared. Okay, make sure you guys include units, and really you really need to know your formulas. Okay. All right, let's go ahead and go on to the next page. Okay. So it says find the area of the shaded region formed by an equilateral triangle if the radius of its inscribed circle is 6. So first go ahead and write out how you're going to find the area. So area of the equilateral triangle minus the area of the circle, and then plug in the formulas. So √3/4 s squared minus pi r squared. Okay, so to start this problem, we're going to go ahead and draw in the radius, which is 6. And then, as always, we want to complete a triangle to make a right triangle. Okay. Since this is a equilateral, the big triangle is an equilateral triangle, that means that all these angles are 60 degrees. So if we split one in half, that angle right there is 30 degrees. So let's draw this off to the side. So we know this is 6, the right angle, 30 degrees. Okay. The whole point of doing this is we need to find the length of the big triangle on the outside. So since it's across from the 30-degree angle, then to get to one side, this is 6 root 3. Now you have to be really careful because 6 root 3 only explains this portion of the side. Okay. What we have to do is we have to double it to get the full length. Okay. So once again, we found that the long side was 6 root 3, but we had cut that triangle out from up here, and this portion is 6 root 3, but we need the full side in order to use the formulas, which equals 12 root 3 when you double 6 root 3. Okay, now we can go ahead and plug this in the formula. So root 3 over 4 s squared minus pi r squared. Okay, and then from here we just need to keep simplifying. So this is 144 times 3 minus 36 pi. 144 times 3 is 432. So take 432 and divide that by 4, and you get 108 root 3 minus 36 pi units squared. Okay, and you're going to just leave your answer like that, leave it in simplified radical form, no decimals. Okay. All right, so those are the formulas for an equilateral triangle. Now we need to talk about a regular polygon that's not an equilateral triangle. Okay, so the center of a regular polygon is the point that is equidistant from the set of all vertices of the polygon. It is also the center of the circumscribed circle about the regular polygon. And it is also the center of the circle that's inscribed in the polygon. So basically, the center is the center for all three pieces. Another definition we have is the radius of a regular polygon is a segment joining the center to any vertex. Okay. And it's key here that it's to any vertex, not the side of the regular polygons. The radius is to the center to any vertex. Okay. What happens is when we draw a point from the center to the midpoint of any side, this is known as the apothem, or some people say apothem. Okay. So looking at this regular polygon, A is the center. Okay. AB is a radius. Notice that it's connected to a vertex. And then AC is the apothem. Okay, so notice the difference that the radius connects to a vertex and the apothem or apothem goes to the midpoint of the other side, so that would make these two congruent. Okay. All right, so let's fill in some important observations. So only regular polygons have apothems. Okay. All apothems of a regular polygon are congruent. Now the next one's kind of long. An apothem is a radius of a circle inscribed in the polygon. And then a radius of a regular polygon is a radius of a circle circumscribed about the polygon. Okay, so now that we have written down our important observations, let's go ahead and find out what the formula is for a regular polygon. Once again, another formula to put in your notes. Okay. So the area of a regular polygon is 1/2 the apothem times the perimeter. Okay, and in the wording you can see A stands for apothem, P stands for the perimeter. All right, let's go ahead and go to the next page so that we can practice this. Okay. So up top, let's go ahead and rewrite the formula. So 1/2 apothem times the perimeter. So it says find the area of a regular pentagon with perimeter 54.49 meters and an apothem of 7.5 meters. So we're going to write down the formula and then plug in the information. So times 7.5 times 54.49. And since it started in decimals, we can leave it in decimals. So we should get 204.34 meters squared. All right, let's go to the next example. It says find the area of a regular hexagon with an apothem of 5√3 and each side is 10 centimeters. So notice that they gave you the side and they didn't give you actually the perimeter like they did in the first example. So you need to see how many sides there are. So a hexagon, 6 sides. So we have to multiply this for the perimeter. So area equals 1/2 the apothem times the perimeter. So 1/2 times 5√3 and then 6 times 10 in parentheses to represent the perimeter. Okay. So you have to pay attention to what information that they're giving you and see if you need to find any other pieces of information. Okay. So then when we multiply this out, we should get 150√3 centimeters squared. Okay, so of course the problems have to get tougher. So it says find the apothem, area, and perimeter of the equilateral triangle shown below. So if we look at this equilateral triangle, currently we have the apothem. Okay, let's draw in our right triangle. Since this is an equilateral triangle, these are all 60 degrees, but if you split one in half, this is 30. Okay. So currently, we have the short side, because the short side is across from the 30-degree angle. Okay. So then that means the long leg is going to be 7 root 3. But like a previous problem, that only covers this portion right here. We need to double this, and the reason why we can double it is because remember the apothem meets at the midpoint of the other side. So this is 14 root 3. Okay. So now we have our information to plug everything in. So the apothem is 7. That was given to us. The area is 1/2 the apothem times the perimeter. So that's 1/2 times 7 times 3 times the length of the side, so 14 root 3. Go ahead and multiply this out, and you should get 147 root 3 units squared. Okay. And then for the perimeter, that's just going to be this portion right here, 3 times 14 root 3. And that gives you 42 root 3 units. Remember that perimeter is not squared, it's just the units. Okay. And we multiplied it by 3 because that's the number of sides in a triangle. Okay. Once again, biggest thing here is to remember to double the full length. Alright, let's go ahead and move on to the next example. It says, find the area of a regular hexagon with side lengths of 8. Okay. So first thing we need to do is find a central angle. And here's a central angle. Remember, it's created by 2 radii at the center. So it's always going to be 360 degrees around here. This completes a full circle. So we're going to take 360 and divide it by the number of sides. Okay. So you get 60 degrees. So that means each central angle is 60 degrees, and there's going to be 6 of them for the 6 sides. So 1, 2, 3, 4, 5, 6. Okay. This is going to help us create a triangle. Okay. And since we are only doing half of it, then that means the angle right here is 30 degrees. Okay. So let's go ahead and draw that off to the side. So this angle is 30, right angle 60 degrees. So we know that the side lengths are 8, okay, but that means the full length of this is 8. But I'm only working with half the triangle. So the portion of it is going to be 4. I was given the 30-degree angle, so across from that is 4 root 3, which equals the apothem. Okay. Now notice that step 3 said to use special right triangles or trig, SOHCAHTOA, to find the necessary information. Okay. So we've primarily been using special right triangles, 30, 60, 90, 45, 45, 90, but in a few examples we're going to be using trig to find either the apothem or the missing side. Okay. So we can go ahead and find the perimeter. We know that each side is 8 and there's 6 sides. Okay. And then we need to find the area, which is 1/2 a times p. So 1/2 times the apothem, which is 4 root 3, times the perimeter that you just found. And we should get 96 root 3 units squared. So just kind of to recap here, we first have, when doing these types of problems, you first need to find a central angle, and you do that by always taking 360 and dividing by the number of sides. Okay, I'll say that again. To find the central angle, you always take 360 divided by the number of sides. Now, of course, n can change depending on the number of sides. Okay. Then you need to find missing information, so you need the side length and the apothem. Well, we were given the side length, but we did have to find the apothem by using special right triangles. Then from there, we just plugged it into the formula. Okay. All right. We aren't always going to be able to use special right triangles, so sometimes we have to use trig. Okay, and we have 2 examples left, and we'll be done. Alright, so it says find the area of the regular pentagon shown below. So remember that the first thing we need to do is find a central angle. And you do that by taking 360 minus the number of sides. Since this is a pentagon, you would divide it by 5. Okay, pentagon has 5 sides. And that gives us 72 degrees. Okay. Now we're going to use that to go ahead and form a right triangle so we can find the apothem. Okay. And remember, we got to cut that angle in half, so this is 36 degrees. So let's go ahead and draw this off to the side. That was a terrible line. So we know that this is 36 degrees. Here's my right angle. Okay. And the full side length is 10, so split that in half, and that gives you 5. Okay, we can't use a special right triangle because the angle is 36 degrees. So instead, we want to use trig. Okay. So looking at 36 degrees, we need this side, which was given to us, and then the apothem. We don't care about the hypotenuse. So with regards to the triangle and the angle of 36 degrees, remember across from it is the opposite and next to is adjacent. So which trig function out of SOHCAHTOA uses opposite and adjacent? That would be tangent. So tangent of an angle is opposite over adjacent. So tangent of 36 equals 5 over x. Okay, be careful of where you plug in that x. Okay. In this example, it's the adjacent one. So we get x tangent of 36 equals 5, and then to get x by itself, we need to divide by tangent of 36. Okay. Now when doing these types of problems, your answers are not going to be exact because of the trig. Okay, so you're going to have to use the decimal form. So take 5 divided by the tangent of 36, and you should get approximately 6.88. Remember that what we just found was the apothem. Sorry, I did not like how I wrote that. So 6.88. There we go. Okay. Okay, so we have all the information. So area equals 1/2 A times P. So 1/2 times A times P. Now, if I just plug in 10, that'll be incorrect because I need to multiply it by the number of sides to get the full length of the perimeter. Okay. So once you plug this in, you should get approximately 172 meters squared. Now when I did this on my own, I got 172.05 because I didn't round early. I rounded at the end. So as long as you're in the approximation and you show me all your work, you'll be good. Okay. So to recap, take 360, divide by the number size, which is 5 in this example because it's a pentagon. Okay, then split that in half to work with our triangle. So 72 divided by 36, 2, is 36. Can't use special right triangles, so we have to use SOHCAHTOA. Opposite over adjacent is tangent. Okay, solve for x, which in this case represents the apothem. Okay, and then just use the formula. All right, go ahead and stop the video and go and try number 5 on your own. You will have to use trig again. You can't use special right triangles on this one. So go ahead and try 5 and stop the video, please. Okay, so here is the answer. Notice that you guys had to use trig twice because you were given the hypotenuse and which is the radius of the polygon. And that doesn't help us at all to find the area. So you had to find the apothem as well as the side length. Okay, so to find the apothem, that's the green. I used cosine, adjacent over hypotenuse. And to find the side length, that's the blue. I use opposite over hypotenuse, which is sine. Make sure you double this to get the full side length, and then plug it into the formula. Okay. Go ahead and leave this up as long as you guys need to go through it. You're going to get a new homework packet today, worksheet, and you're going to work on worksheet 9.4. I already posted the answer key so you guys can check your work as you go. Remember to try it first and then check your answer. Please just don't copy things down. Okay. I hope you guys all have a wonderful day, and I will see you guys tomorrow, hopefully.